NN-SVG, Neural Network Scalable Vector Graphics, Publication-Ready Neural Network Architecture Schematics by AlexNet in MIT Department of Biological Engineering. So the illustration of neural network architectures are often time-consuming to produce, and machine learning researchers all too often find themselves constructing these diagrams from scratch by hand. NN-SVG is a tool for creating neural network architectures, drawing parametrically rather than manually. It then provides the ability to export those drawings to Scalable Vector Graphics, that is SVG files, suitable for inclusion in academic papers or as figures on web pages. The tool provides the ability to generate figures of three kinds: classic fully connected neural network, FCNN figures, convolutional neural network, CNN, and deep neural network figures. Let's have a look on NN-SVG. Here you can see that you have different tabs, and in each tab you have different styles of NN-SVG. The first one is FCNN style, and you can see that this is the FCNN in which all these are fully connected layers. The next one is LeNet style. You can see that this one is the LeNet style. The next one is AlexNet style. So whatever you want, you can include in your academic papers and on the web pages as well. And also we have different parameters to change this architecture. This is the default architecture that you are seeing right now. Now coming back to the FCNN style, you can see that we have different layers in this FCNN. The first layer is the input layer, and you can see that we have 16 nodes over here. So these are the 16 nodes in the input layer. Next, we have the hidden layer, this one, and in this hidden layer, we have 12 nodes. Now coming towards another hidden layer, you can see that we have, over here, we have 10 nodes in this hidden layer. Now, the last one is the output layer, and in this output layer, we have only one node. This is the default setting of the neural network. You can change the parameters. You have all the options of changing the number of nodes in the input layer, the hidden layers. You can change the edge width and all that you want to change. You can even change the colors of these nodes. Now you have the different parameters to change the architecture, to change the appearance of this neural network. First of all, look at this edge width. We have this option. We can decrease or increase the edge width. And similarly, we have the edge opacity. We have the slider over here as well. We can increase or decrease the edge opacity. You have the option of changing the edge colors. You have the negative edge color. You have this panel and colors. You can select any color out of that. For positive edge colors, you have again, you can select any colors out of that. And for default edge color, you have these options. The other option, we have node diameter. You can simply move this slider and increase the diameter of these nodes or decrease the diameter of these nodes. Now we have an option of layer spacing. You can see that we have the slider for that. We can decrease the layer spacing. You can see that the distance between these layers have been decreased, and we can also increase this space between these two layers. And you can see that we have another option of this direction. You can see that we currently it's selected as horizontal. We can also select it as a vertical. You can change the architecture of the neural network by changing these text boxes. Currently we have 16 over here, which indicates that we have the 16 nodes in the input layer, and then we have the 12, which indicates that we have the 12 nodes in the second layer, which is the hidden layer, and then we have the 10, which shows that 10 nodes in the third layer and 1 in the last layer, which is the output layer. You can simply change them by typing whatever you want. Let's suppose I type 20 over here and press enter. The nodes will be changed from 15 to 20. The number of nodes have been increased. And you can see a slider over here. When I change the slider, I've observed that all the node distance have been increased. So when you change the slider, and the distance increases and decreases accordingly. But you have to select the one which is good in appearance. And similarly for the other layers too, we can increase or decrease the number of nodes in this box, in this box, and in this box as well. Currently, we have one output node in the output layer. We can change it into 2, and 2 nodes will reappear. And if your problem is that you need 2 output nodes, you can simply change that. Now come towards LeNet style. You can see that you have now different appearance of this neural network. You can change the color over here, color 1 and color 2. You can see that this is the light gray, which is appeared on this one, and this is a little dark one, and this is appeared over here. Then come towards the filter opacity, and you can change the filter opacity over here. You have different options for that, and also you have the option of border width. You can change the width of the borders. Spacing between the filters, you can also change the spacing between the filters by simply sliding this slider. You can make changes within this neural network. You can see that you have different layers over here. You have the max pool, and you can see that this is for the max pool, and then you have the convolution, this is the convolution, and then you have the max pool again, and then you have the dense layer over here. So in each layer you can make the changes. You have different text boxes over here, and each text box corresponds to one of the parameters. The first one corresponds to the depth, the second one corresponds to the height, the third one corresponds to the width, the fourth one is for filter height, and the fifth one is for filter width. And also we have the option of vector length. Another option is for AlexNet style. The renderer is for both WebGL and SVG. So you have to select one of that, and in that you have different color. For the color 1, you can select any one of that. For the color 2 and for the color 3. Then you have the tensor capacity. You can change this tensor capacity, and filter opacity, and the spacing between the layers. So increase or decrease the spacing layers. Now you have the depth size scaling. Increase or decrease the depth size scaling. Width size scaling. So this is for the width size scaling. Then you have the convolutional filter scaling. And you have also the option of font size. Here you have the option of changing the architecture. You can see that you have different layers over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And you can see that you have different options for height, width, depth, filter height, filter width, and for each of these parameters we have the corresponding text boxes. We can directly change the values over here, and you can see that we have the vector length of 2048, 2048, and the 1000. So the bottom line is that NN-SVG is an amazing tool. We can make different architectures so easily that it would be really difficult if we are going to make these schematics by hand. And you can see that this is really beautiful, that the distance between the nodes are equal, the spacing between the layers are equal, the edges are connected with the other nodes, and it's a complete mesh. Otherwise it would be really difficult for us to connect these nodes if they are going to do it manually. It saves a lot of researchers' time, and with the number of nodes we can directly change the number of nodes within each layer, and there is less chance of mistakes. If we do it manually, it would be really difficult to give the proper spacing, to give the proper appearance to this network. We can change the width of these edges, we can give beautiful colors to these nodes, and with a single click we can change the nodes, the number of layers, the distances, and it's really amazing.